Hello, students. Hope you're doing good. I'm going to go over this new topic on quadratic functions, discuss a little bit concepts with you, and going over some problems. If you recall, quadratic equations are always of this form, which is written in this black box right here. Um, it's ax squared plus bx plus c equals 0, and a is never 0 because if a is 0, then that's not a quadratic equation. Some of the examples of quadratic equations are right here. 3x squared plus 7x minus 5, x squared plus 2x minus 1, x squared plus 7 minus x squared plus 3x plus 1 equals 0. So when we talk about quadratic functions, now it's not an equation, it's a function. We mean functions of this form written right here, which is it's written in the function form y equals a function of x. So I set y equals your quadratic equation. So it's not the quadratic equation, it's now a quadratic function. Either y equals that particular ax squared plus bx plus c, or as you know, we use uh, f of x also for function. So f of x equals ax squared plus bx plus c. Again, a should never be 0. So that's how we write quadratic functions. The simplest example of a quadratic function is y equals x squared, which is the parabola, right? So that's your y equals x squared. This is a quadratic function. The domain of this function, as we have already discussed, is negative infinity to infinity, and range is 0 to infinity. Now, there's another topic which is the intervals of increasing and decreasing in this one. So, intervals of increasing and decreasing. So, I'm going to write here intervals of increasing and decreasing. So what this is asking is, in what interval is your function increasing and in what interval is your function decreasing? First of all, what is increasing and what is decreasing? Increasing means as you go from left to right, is the function going up or is it going down? We always start from negative infinity. So if this is my negative infinity and here is my positive infinity, if I start moving in this direction, as you can see, I'm moving from left to right, but my function is coming down up till this point, which is 0. So the function is going down right here and going up right here after 0. 0 is kind of a break point. So the function is, this function f is decreasing from negative infinity or negative infinity to 0, and increasing in the other interval, which is it's going up as you go from left to right. It's increasing on 0 to infinity. Okay, so now in this particular section, you will be asked to analyze these quadratic functions. You will be asked to graph these quadratic functions by answering some of the problems, some of the questions about these. For example, what are the intervals of increasing, decreasing? What's the domain? What's the range? Now, quadratic functions, that y equals x squared right here is the basic one. But usually you can write any quadratic equation and set it equal to y, and that will be your quadratic function. So more information about quadratic functions. They are of this form, which we have already discussed. All of these have a the parabolic shape right here. So all of these are U-shaped. They can be anywhere in the two dimensions. Your x square is right there, which passes through 0. But if you'd give me any other quadratic function, they could be anywhere in this space. They could be upside down also. Okay, so these are the three examples of quadratic functions drawn on the two-dimensional space. Now let's look at some of the properties of these functions. I'm taking two examples right here, the red one and the green one. So all those questions will be pertaining to red. If I'm writing with red color, I have this function in mind, this one right here. That's my red one right here. And if I am writing my green one, my function is negative x squared plus 7x minus 12. So I will be answering all those questions related to these two, the red problem and the green problem. First of all, when do we know the parabola opens up or down? if the coefficient of x square right here is positive, your parabola opens up. If it is negative, for example, in the green problem, it's negative, the parabola is going to open down. Okay, so opens up if a is 0 and opens down if a is if a is positive, and if a is negative, it opens down. Now the domain of these functions is always negative infinity to infinity. You can input any value of x, they extend indefinitely from left to right. So that you already know about parabolas. Now intercepts, that's another concept. To figure out the intercepts, to figure out first of all x-intercepts, you set y equals 0. And to figure out y-intercept, you set x equals 0. Let's look at these two red and green problem. If I set my x equals 0, my first two terms are gone in both the cases. And in the red problem, my intercept is 3, y-intercept. And in my green problem, my y-intercept is negative 12. So already we know y-intercepts, right? To find the x-intercept, you set y equals 0. So if I want to find x-intercepts, I set y equals 0, which is right here. My equation becomes something like this. 2x squared minus 5x plus 3 equals 0. But that's a quadratic equation, and we have already learned about quadratic equations, solving quadratic equations. To solve this quadratic equation, you can either factor or use quadratic formula. I can factor here because the sum, because these are the things we need to factor. If I can find a pair of numbers which satisfies that sum is negative 5 and product is 6, then I can factor. Now in this case I can, because I have negative 2 and 3, and you have learned before how to split the middle term with negative 2x minus 3x plus 3, and my factors are coming out to be, this is my factored form right here, x minus 1 and 2x minus 3. So from the first one, x is 1 or x is 3 halves. So that means these are my two x-intercepts. X-intercepts means where my parabola is going to cross x-axis. Okay, so the two x-intercepts are 1, 0 and 3 by 2, 0. Y-intercept, as already discussed, is 0, 3. Similarly, we can find the x-intercepts of the green function above right here, minus x squared plus 7x minus 12. And I leave it up to you. To figure out the x-intercepts, I found out that those are 3, 0 and 4, 0. You can try either factoring or quadratic. And similarly, y-intercept is 0, negative 12. Okay, so try definitely factoring. Now the other thing is, this is something new, finding the vertex of a parabola. Now vertex of a parabola, if you have this parabolic shape, the lowest point, if it opens up, the lowest point, and if it opens down, the highest point is called the vertex. For example, in the case of y equals x square, this 0, 0 is your vertex. The coordinates of the vertex are 0, 0. Now here you will be asked to find the coordinates of vertex. Coordinates of vertex are given by this formula, and of course you can use this formula for exam. It's negative b over 2a and the function evaluated at negative b over 2a. Let's look at the example. I'm taking my red example, 2x squared minus 5x plus 3. What's your a? A is the coefficient of x squared, b is negative 5, the coefficient of x, and c is 3. Plug those numbers into this formula, negative b over 2a right here, negative b over 2a. Negative of b, which is negative 5, over 2 times 2, which is a. Solve this first. Negative, negative becomes positive, so it's 5 fourth. So the x coordinate of the vertex is 5 fourth. Plug this x coordinate. So I'm asking you, what is f of 5 fourth? That's your y coordinate. So you can use your calculators here. Plug this 5 fourth into your into the equation, which is right here. That will give you the y value of the vertex. So if I want to find f of 5 fourths, I use the same equation, 2x squared minus 5x plus 3, and I use x equal 5 fourth, right? So I get, when I simplify, I get negative 1/8. And you can look at the simplifications, how I have done these. This is 25 by 8, 25 by 4 plus 3. You can use your calculators, and it's negative 1/8. So the coordinates of vertex for the red curve are 5/4 and -1/8. So this is my x and this is my y. Similarly, for the green curve, you can figure out yourself. The coordinates of the vertex are 7/2 and 1/4. So it's coming out to be the x coordinate is coming out to be 7/2, and then plug in 7/2 into the equation, which is minus x squared plus 7x minus 12, and that's you get 1/4. So the y coordinate is 1/4. So we have coordinates of vertex for both. The next important thing is the axis of symmetry. Each of your parabolas has an axis of symmetry. For example, y equals x square has axis of symmetry, which is your y-axis, right? All the parabolas are symmetric about some kind of vertical line. The parabola y equals x square is symmetric about y-axis, which is x equals 0. So if I want to find the axis of symmetry for your any given parabola, this is your vertex, right? The line passing through the vertex must be the vertical line passing through the vertex. I can see the parabola is symmetric about that line, and that's your axis of symmetry. But how to write the equation of that vertical line? Since this line passes through x equals negative b over 2a, whatever that number is, x equals that particular number is your vertical line, right? For example, in the red curve, your vertex is 5/4, comma -1/8. For example, this is my vertex right here. The coordinates are 5/4 and -1/8, right? So I know the vertical line that passes through the vertex is the axis of symmetry. But since this line is vertical, it has the form x equals a number. What number? That number must be 5/4 because it passes through 5/4, right? So the axis of symmetry is x equals whatever the x coordinate of vertex. Similarly, for the green curve, it is x equals 7/2. Now let's draw the two functions. The last part is graphing them. The red one, if you remember, let's write everything here. So the red one right here, what were the intercepts? If you remember, the x-intercepts were 1, 0 and 3/2 0. And that's what I have plotted here. This is my 3/2 0, and here right here is my 1, 0. What was my y-intercept? My y-intercept was 0, 3, and I believe this point is 0. It's not 3.25, it's 3. 3.25 is actually that particular line over there. So the blue dot right here is 0, comma 3. Okay, then what was the coordinates of vertex? The coordinates of vertex are 5/4 and -1/8, which is right here. 5/4 is 1.25, and then -1.8. So this is kind of negative 1.8 right here, -1/8. Okay, it opens up. We know it opens up, right? Um, what else? Its domain is always negative infinity to infinity. Talking about its range, what do you think will be the range for this one? I'm sorry, where did I go? So the range of this will be the lowest y value up till the infinity. Now the lowest y value is on the vertex, and what's the y value here? -1/8. So the range of this right here is -1/8 to infinity. So the lowest y value all the way up to infinity. Lowest y value, which is the value of the vertex, to all the way up till infinity. Let's look at the green one. For the green one, the intercepts were 3 and 4, right? So the intercepts, if you look, the x-intercepts were 3, 0 and 4, 0. The y-intercept is -12, which is right here. As you can see, it's crossing y-axis at -12. The coordinates of vertex is already 7/2, and which is 3.5 and 1/4. And I haven't drawn the axis of symmetry, but it is symmetric about x equals 7/2. Now, what is the domain? Domain again is negative infinity to infinity. But the range for this one, since it opens down, it will be something from, so this one opens down because of the negative coefficient of x square. The range of this one will be negative infinity to the highest point of the vertex y value, that's 1/4. So if you go down and see, the range is negative infinity to the 1/4, which is the y value of the vertex. Let's look at the increasing, decreasing now. For the intervals of increasing, decreasing, the first one, the red one, it is decreasing up till the point, the x coordinate of the vertex, which is 5/4, and increasing afterwards. So it's decreasing first. Let's write here. So this one right here is decreasing first and then increasing. Arrow going down, arrow going up. So the first one is coming down, decreasing on negative infinity to 5/4, and that's your x coordinate of the vertex. You always look at the x. And it's increasing on same, that's 5/4 is the break point, 5/4 onwards. The other example, the green one, is the opposite. It's increasing first, right? And then decreasing. So for the green curve, it's increasing from negative infinity to 7/2 and then decreasing on 7/2 to infinity. As you can see, it's written here. So I would want you to to try this problem one and discuss it in the discussions. Do all of these. Repeat it for x squared plus x plus 2. The only thing is, in the example f of x squared plus x plus 2, I cannot factor it when I'm finding the intercepts, because for the intercepts you have to set it equal to 0. If I use quadratic formula, I find non-real intercepts. So it means this kind of parabola does not cross x-axis. So since it opens up, it's directly above x-axis. It's either here or here. So it's above x-axis. It's not going to cross x-axis. As compared to right here, as you see, these parabolas are crossing x-axis at two intercepts. Okay, so this will look something like the red one right here. It's strictly above x-axis. Okay, so try this one as well and then repeat the same for the other two problems as well. See what's happening in the other ones. I have some hints right here, and do all those steps: domain, range, intercepts, vertex, axis of symmetry, and increasing, decreasing. That's it for me now. And let me know if you have any question. Take care. Bye bye.